Hi everybody. In this video I'm going to use vector algebra to solve for an unknown displacement on a north, south, east, west grid. Before I get into the problem itself, let's talk about the directions in the coordinate system. So here's my north, south, east, west directions. Here's my coordinate system. So I'm taking the positive x direction to be east, the positive y direction to be north. Consequently, that means the negative direction I've chosen to be south, and the negative x direction to be west. All right, I'm going to locate my home at the origin of this coordinate system. All right, so here's the problem. Imagine I'm given a displacement vector from home to my favorite bakery to be labeled by this vector A, and let's say that vector A is 2 kilometers, 20 degrees north of east. That means orient myself to the east, then turn 20 degrees to the north, so that's the 20 degrees north of east. Go 2 kilometers in that direction. That's the displacement vector from home to the bakery. I'll label that displacement with the vector A, and the magnitude of that is A without the arrow over it, 2 kilometers. Great. Likewise, let's say I'm given the displacement vector from my home to the gym. Gym's here. Here's my home. And the displacement vector to home to gym is 3 kilometers, 50 degrees north of west. That means orient myself to the west, then turn 50 degrees toward the north. So that's the 50 degrees north of west. Then go 3 kilometers in that direction. That gives me the vector B, the displacement vector from home to gym. Okay, so here's the problem. In this problem, I'm asked to find the displacement vector from gym to the bakery, which I'm going to label with the vector D. Let me just take a moment to draw that vector in. Here's our vector D, the displacement from gym to the bakery. All right, and that's what I want to find. Now you might think, oh, well, gee, we've done these before. All I got to do is take vector A plus vector B. That will give me this vector D. Wait a minute. Vector A plus vector B is not going to give me vector D, because let's think about what vector A plus vector B would be. To get vector A plus vector B, I'd have to take vector B and port it over here so that the tail of vector B was located at the tip of vector A. So I have to take this, bodily bring it over to here. So my vector B would be sitting right here, so I'd have vector A plus vector B, and the net result of that, vector A plus vector B, would be from home to here. That's not what I have. I'm looking for this vector D. What I need to do is write a vector equation that matches the picture that I have here. And often the simplest way to do that is just to identify the actual vector addition in the problem. All right, so that means looking for vectors that are connected tip to tail. Well, we see that right here. Starting here, I've got a tip and I've got a tail. So this is vector B, that's vector D. So this is vector B plus vector D. So vector B plus vector D takes me from here to here, but that's equivalent to vector A. So my vector equation is vector B plus vector D gives me vector A. Now, I can rearrange that to solve for vector D. Just subtract vector B from both sides. All right, so that's my vector equation. Now, this will hold true for both the components. So this will be true for both the x component and the y component. So I can write those down now. All right, so my job basically then is to find these components, a sub x, b sub x, a sub y, and b sub y, and then from those I'll get the components d sub x, d sub y of this D vector. All right, let's break those components up. So in working with these components, I'm going to first identify them on this picture here. So let me do that. So here's my x component of vector A, which I'll call a sub x. Here's my y component of vector A, which I'll call a sub y. I'll label those. Now, before we figure out those components, let's just remind ourselves of the trigonometry of right triangles. All right, if I have a right triangle here and I identify some angle, all right, well, the longest side of the right triangle is the hypotenuse. The adjacent side of that right triangle will have a length equal to hypotenuse times the cosine of that angle, right? The adjacent side is identified with the cosine. The opposite side of that right triangle will have a length equal to the hypotenuse times the sine of that angle. So sine is associated with the opposite side. Great. And then just to remind ourselves, the tangent of this angle will be the length of the opposite side divided by the length of the adjacent side, and we'll use that later in another part of the problem. Okay, so let's identify the right triangle here. I have a right triangle right here. This magnitude A, that's the hypotenuse. Here's the adjacent side. All right, so A sub x will equal A magnitude, which I won't write in there, but that's 2 kilometers, times the cosine of 20 degrees. And I'll just write out that number. A magnitude is 2 kilometers, so 2 kilometers times the cosine of 20 degrees gives me 1.879 kilometers. All right, while I'm at it, I might as well find A sub y. I don't have room to write it here, but I'll write it down here. A sub y. Well, A sub y, that's the side opposite to this 20-degree angle. So I'm going to have A magnitude times the sine going with the opposite side of 20 degrees. And that's going to give me 0.684 kilometers. Okay, one important point that I almost left out. All right. A sub x is in the positive x direction. A sub y is in the positive y direction. You can look at the directions of those arrows. So these should come out positive. Sometimes you have to put the signs in by hand. If you're measuring the angle from the positive x-axis, the positive or negative will come out in the wash. But over here, I'll be doing something different. I won't be measuring from the positive x-axis, so I'll have to put the positive or negative in by hand. Okay, let's do the same thing for vector b. B sub x, B sub y. Put my arrows in. All right, so there's B sub x. That's in the negative x direction, so it's going to come out negative. There's B sub y. That's in the positive y direction. It'll come out positive. All right, now I can use my trigonometry again. So I'm going to identify this right triangle. Here's the right angle. Here's the hypotenuse. Here's my 50-degree angle. This side is adjacent to the 50-degree angle. All right, so B sub x. Now I got to be careful. If I just go B magnitude times the cosine of 50 degrees, I'll get the length of this, but then I need to put the negative sign in by hand, because 3 kilometers times the cosine of 50 degrees will give me a positive number. But I need a negative number because this component is negative. All right, so minus B cosine 50 degrees. I'm going to write that number out here. Plugging in 3 kilometers for B, multiplying by the cosine of 50 degrees, that gives me negative 1.928 kilometers. And correction, the negative is just coming from the negative sign I put in by hand. The 3 kilometers cosine 50 degrees is the 1.928 kilometers. Okay, great. Same thing for the opposite side. Opposite side is associated with sine. So the amount of this will be 3 kilometers times the sine of 50 degrees. And it's also going to be positive. And I'll write out that result. B sub y comes out to be 2.298 kilometers. Okay, so we've got everything we need. We can plug those things into here. So let me just do that. The x component of vector d, well, you know what? Let me actually just draw those components in just so we can look at them. All right, so here's my vector d. I can draw in my x component and my y component. That's supposed to be a right angle right there. All right, so here's my vector d. I could go this much in the x direction, that much in the y direction. Those are the x and y components of the vector d, respectively. All right, and I can get those from here. So let me just plug these numbers in. And I'm just going to write them here so we see the algebra. A sub x, that was 1.879 kilometers. I have to subtract off b sub x. B sub x is minus 1.928 kilometers. Now look what's happening. I've got minus a minus. So that gives me a plus. And I have room to put that right here. D sub x comes out to be positive 3.808 kilometers. Now, before we do d sub y, let's just look at that. All right, here's my 1.879 kilometers this way. Then I'm subtracting this thing this way. The subtraction of this would give me something like that. So basically I'm adding an arrow that would go from, I'm adding this arrow to the negative of this arrow, which is an arrow like that. So basically I'm adding those two arrows up. That gives me that. So that's the picture, that's the graphical picture that goes along with this component addition. All right, let's do the y components. A sub y, that was 0.684 kilometers. Then I have to subtract off b sub y, 2.298 kilometers. And the result there is going to come out negative. That comes out negative. That comes out to minus 1.614 kilometers. All right, now let's just look at the graphical representation of that. Here's my 2.298 kilometers, but I've got to subtract that. So that would turn this arrow around here. So I would have a downward arrow from here all the way down to here, but then I've got this upward arrow, that's that. That just leaves me with this. All right, and so this amount is 1.614 kilometers, but it's a negative y direction, so that's why we have a minus sign. All right, so I can write this in our vector notation. My vector d, that's the displacement from the gym to the bakery, is 3.808 kilometers x hat plus a negative 1.614 kilometers y hat. And if you want, you could take this minus and distribute it out there. That is displacement from the gym to the bakery in unit vector notation. If I prefer, I can use I hat instead of X hat, and I can use J hat instead of Y hat. Those symbols are interchangeable. All right, I can also write this in magnitude and direction format. So remember, the magnitude of a vector is equal to the square root of the sum of the squares of the components. All right, so all I have to do is take this, square it, take that, square it, add those squares, take the square root, and I get 4.14 kilometers. 4.14 kilometers, that's the magnitude of the vector d, which I just have d without an arrow over it. I can also find this angle. If I identify this angle here, that would be an angle from east going south. So this would be an angle south of east. I'll just call that theta. All right, so using this expression and then taking the arctangent of both sides, the arctangent of the tangent of theta would give me theta. Then I'd have the arctangent of the right-hand side, which would be opposite over adjacent. But opposite is, well, I'll just write that right here, opposite over adjacent. All right, now plugging in arctangent. My opposite side is really the absolute value of this d sub y. And my adjacent side is the absolute value of d sub x. And I'm using absolute values just to ensure that this angle comes out positive, so I don't have any negative signs to fiddle with in my arctangent. So I'm just treating this as a physical triangle. I'm not making this, I'm not saying like I'm going from here to here and calling it a negative angle. I just want to know the amount of that angle. That's what I'm looking to do here. All right, so my d sub y, absolute value, I'd take this, take the absolute value of it. So 1.614 would go here, 3.808 would go here, the kilometers over kilometers would cancel, take the arc tangent, and I get that theta equals 23.0 degrees, and that angle, that's from here to there, so that angle is south of east. So I'm about out of space. I think I might be able to put it down here in magnitude and direction format. My vector is vector d equals 4.14 kilometers in the direction 23.0 degrees south of east. All right, a couple comments. Let's do some reality checking. For the magnitude 4.14 kilometers, well, is this plausibly 4.14 kilometers long? Well, this was 3 kilometers. This is longer. Looks like it could be about 4, so looks okay. Is this about 23 degrees? Well, you know, I don't have a perfect, didn't draw that perfectly level there. But if this is 20 degrees, that looks plausibly about 23 degrees. So assuming I made a decent sketch, these numbers look like they at least check out in the ballpark, or my sketch is reasonably consistent with that. I could have asked another question. What's the displacement from the bakery to the gym? That vector would be minus d. In other words, if this is d, then minus d would be the other way. Minus d has the same magnitude as d, so the magnitude of minus d would also be 4.14 kilometers, but minus d would be in this direction. What is that direction? Well, if this direction is, if this angle is 23 degrees, we could draw a parallel line to this right here, and then from here to here would also be 23 degrees. So going from there to there would be 23 degrees north of west. All right, so that would be the displacement from bakery to gym would be 4.14 kilometers, 23 degrees north of west. All right, so we didn't ask for that, but we could have. Okay, so I hope that helps. Thanks for watching, and I'll see you next time.